Here's how I made a 2-hour query take only 76 seconds. There are essentially two parts to this. First off is the database optimization with indexes, and secondly, it's the programming language, fetching the SQL queries in parallel instead of sequentially. Because I was doing a lot of queries in terms of database requests, and now I'm doing it in parallel. These are the two parts. Let me start off first with the database optimization. How I made a 7-minute query, a single SQL query take from go from 7 minutes down to less than a second, 0.7 seconds. Two things: indexes and not using all in joins, because this way, if you use all in joins, you cannot use indexes, at least in MySQL. It does not recognize them. So let me start with the first query, which was 8 minutes, and then I'll tell you how I optimized it. Essentially, we have this is an e-commerce store, and we're trying to count how much products there are in each category. There are 3 levels of category. Now I'm looking only at the 3rd level, so leave out the others. A single table. Now, I'm selecting from pod menu, which is the 3rd level category. I'm doing a left join with catalog, which is the products table. And since each product can be on 3 different categories all at once, this camera is going wild. In catalog, I have menu pod 1, and menu pod 2, which are in which in which 3rd category, in which pod menu the product can be. Because it could be it could be in 3 different 3rd categories, in the 3 different pod menus. Now, even when I added indexes, this is the interesting part. No, I added indexes on menu pod 1, and menu pod 2, because I'm using them as foreign keys, and they were just normal columns. So before the indexes, man, what the fuck is going on? Before the indexes, MySQL had to go through all of the catalog table, which is 200 plus thousand columns, rows, and it had to search exactly for this value of the menu pod 1, menu pod 2. But when I add indexes, it finds it instantly. And the thing is, if you use foreign keys, you need to add indexes. Either a foreign key index or just regular index. So I added these indexes so that MySQL can instantly find to which category ID the product belongs out of the 3. But that didn't fix it. It was this OR. I'm not too sure why MySQL didn't recognize the indexes, but when I removed the OR, so essentially I broke down this absolute same query into this. This is the first query. This is the second query. This is the 3rd query. Because this query searches for the single product, and then it loops through the menu pod 1, menu pod 2 to find if it belongs somewhere. But in the other queries, it's absolutely the same. It's just I removed the OR. It searches for the product, then only searches for the first possible connection to the category, and then searches for the second possible connection to the category for the product, then searches for the 3rd possible and last connection to the category. Just 3 queries that do the same thing as this one. because it doesn't loop through the possible solutions within each product. I made this into separate. And when I made them into separate queries to only look at one foreign key at a time, it recognized the indexes. And that's when it went down to 0.7 seconds when you have indexes on foreign keys. That was the first part, the database optimization. 7 minutes down to 0.7. Now, for the other optimization, we use PHP, which ran these queries sequentially. So one query, wait for it, one query, wait for it, one query, wait for it. But now I'm using JavaScript, which can run async functions in parallel with this promise.all. So I'm sending a batch of queries, 19 websites times 3 categories times 3 queries. It's about 150 queries. I haven't calculated, I don't care. It's more than 100 queries, which I'm sending at once. But with the PHP, I had to send one by one. And that was the second part. So key takeaway, use indexes, don't use all in joins, so that indexes can actually be used. And run queries in parallel if possible with your programming language. Hope you enjoy. Bye.